Good morning, children. We proceed on to Chapter 6, Random Variable and Mathematical Expectation. What is a random variable? Let us understand this concept using an example. Consider a coin is tossed 2 times. A coin has 2 faces, head and tail. A coin has 2 faces, head and tail. When I say 2 times, and let me consider number of heads that I would get. Tell me the outcomes. It could be tail, tail. It could be head and tail, or tail and head, or it could be head and head. I toss a coin 2 times and I declare getting the number of heads to be my expectation now. How many heads would turn up? No heads at all, at least 1 head, and both are heads. No heads at all. Number of heads is 0. 1 head is there either in the first toss or in the second toss. So here I declare h is equal to 1. In this case, both are heads. So h is equal to 2. Number of heads is 2. Number of heads is 1. And number of heads is 0. This number of heads I declared as a random variable. So what would be my x values? X I declare number of heads. What would be x values? 0, 1, 2. What is the chance of getting 0? The chance we declare as P of x. When all I get 0, only in one case I am getting 0. Out of how many cases? 1, 2, 3, 4. Totally there are 4 cases in which one time alone I get h is 0. So what is my answer? 1 by 4. Where and all I get h is equal to 1? 2 cases out of 4 cases. So my answer is 2 by 4. When I get h is equal to 2, 1 case out of 4 cases. So this by 4 tells me how many possible outcomes are there. This numerator tells me the declaration of my condition, number of heads. So number of heads is can be 0, 1, 2. Here I must see where and all I get 0 heads, only 1 case. Here I see where and all I get only 1 head, 2 cases, 2 out of 4. Here I see only 1 case, both are heads. So my answer is 1 by 4. Now framing this table we call probability mass function. In short, PMF. So this exercise we are mainly learning about random variable and PMF. This PMF tells me probability mass function. And can I say I want 0.5 heads or 0.1 heads? So these are not possible when I declare number. Number of students should be a whole number only. Number of phone calls should be a whole number only. Number of defective cases should be a whole number only. So these are called the word discrete. So the word discrete tells me it is a whole number. Majority, we do not have decimals in between. I can put them all in discrete. number of students, number of productions, number of cases, number of calls. These things cannot have 0.1, 0.3, 1.7. So such decimals not allowed. These cases we put under the head discrete. But if I say weight, you cannot be suddenly from 2 kg to 3 kg. Weight is a continuous process. You cannot be from 3 feet to 4 feet immediately. You have to grow day by day. So growth is a continuous process. So many cases, whole number alone is not possible. I may have any number from 0 to 10. I may have any number from 0 to half. So in this case, it is called continuous. So when I say random variable, we have it in two heads. Discrete random variable, continuous random variable. So now let us discuss discrete random variable. How will I say the definition of it? To put it in easy words, we call a random variable is a function, I can say. The domain is set of all possible outcomes and the range is the real numbers. Look at this example. Domain is set of all possible outcomes. 0 heads, 1 head, 2 heads, like that. The range is not a whole number. Definitely, probability is a decimal between 0 to 1. So my answers here will be mostly from 0 to 1 only. So the range is a set of real numbers. We say range cannot be whole numbers. So it is a set of real numbers, and this is redefined as a definition in page number 125. A random variable is a real valued function. Why do I say real valued? My answer is a real number. So it is a real valued function on a sample space. Yes, this we call sample space. When I put commas, I call this as a sample space. So on a sample space, yes, and taking values from minus infinity to plus infinity. This is nothing but the set of real numbers. So we will do problems based on PMF and CDF. What is this CDF? CDF tells me f of x, capital F of x we say. This is probability of x less than or equal to x. Capital F of x equals to probability of x less than or equal to x. Exercise 6.1, question number 1. Construct a cumulative distribution function. X0, 1, 2, 3, probability 0.3, 0.2, 0.4, 0.1. When I see the problem, what all I understand from this? Probability is always positive. P of xi greater than or equal to 0. Total probability 0.3 plus 0.2, 0.5, 0.5 plus 0.4, 0.9, 0.9 plus 0.1, 1. When I add all the probabilities in the table, my answer is 1. We call total as sigma. Sigma P of xi is equal to 1. Now these we understand from the question. What is my question? Construct cumulative distribution. The word cumulative distribution we call capital F of x equals to probability below. Let us remember the idea. F of x tells me probability below that number. So P of x less than or equal to x. Now in the table, below 0 there is nothing. The table starts from 0. Now Less than or equal to 0 tells me first value 0.3. When I come up to less than or equal to 1, add these two. 0.3 plus 0.2, my answer is 0.5. So below 1, it is 0.3 plus 0.2, which is nothing but 0.5. When I come to below 2, add all. So 0.3, 0.2, 0.4. 0.5 plus 0.4, 0.9. 0.3, 0.2, 0.4. Adding all, my answer is 0.9. When I come to less than or equal to 3, add all the values. 0.3 plus 0.2 plus 0.4 plus 0.1, which is nothing but 1. So when I write capital F of X, my answer would start from 0 and end at 1, because probability below the given value is definitely 0. Probability below or equal to the highest value is always 1. Remember, in all the f of x table, the final answer is 1. Now, instead of writing this, you can also add here and write it. 0.3, 0.3 plus 0.2, 0.5, add all the 3.9, add all the 4, 1, and remember to write C, D, F in the left. So, C, D, F is equal to P of X less than or equal to X. This is a better presentation, or else you must be able to write at least like this way. Exercise 6.1, question number 2. Construct CDF of X. CDF, cumulative distribution function of X, and plot it. Given a function like this, at 3.3, at 5.2, at 8.3, at 10.2, otherwise 0. How to write capital F of X? Remember, the very first value we put 0. When X here equal to 3, the question starts at 3. So we will say below 3, the cumulative distribution function is 0. Always remember, below the lowest number, I have to put 0. When x is 3 or below 5, equal to 3 or below 5, my answer is 0.3, the very first value. When x is, here what is the next value? 5. Equal to 5 or below 8. Below 8 implies I have to add these two. 0.3 plus 0.2 gives me 0.5. When x is equal to 8 or below 10. If it is below 10, add all the 3. 0.3, 0.2, 0.3. If I add 0.8, and if it is 10 or above, my answer is adding all the 4, so it is 1. So writing this we call CDF of X. Let us see once again. Below 3, my answer is 0. Below 5. Below 5 is 0.3, but you cannot be writing fully below 5 because we want to plot it. So when my value is 3 or above, below 5, add these two. 5 or above, below 8, add all the 3. 8 or above, below 10, add all the 4. And whenever it is equal to or more than 10, my answer becomes 1. Remember, below the lowest value, it is 0. Above the highest value, it is always 1. Now, how to understand this idea? In your class, there may be 10 children getting below 40. How many children are getting below 50 implies below 40 children plus 40 to 50 children. Similarly, below 60, if I want, below 50 children plus 50 to 60 children. That is what we have done. Every time we have added. Suppose I ask you, how many of you got below 100? The entire class will stand because 100 is the highest mark. So the entire class only we say 1. If I say 101 below, all will stand. If I say 102 below, that is the idea. Highest to value 10 implies above 10. If I ask you 11, 12, 13, anything, my answer is 1 only. Highest mark is 100. So 100 equal to and below implies all will be coming into that. More than 100, any number I say, the entire class must stand because 100 is the maximum mark. So whenever we write CDF, below the lowest value 0, above the highest value, it is always 1. Now how to plot it? We have marked along x-axis these values. The highest value 10. So let us mark from 1 to 10. F of x starts from 0 and the highest value is 1. Capital F of x denotes CDF. Let us write it correctly. So this chapter we have small f of x also, noting PDF. So let us write capital F of x for CDF, cumulative distribution function. 0 to 1, we have marked 0.1, 0.2 like that way. How to graph the function? F of x equals to 0 when x is below 3. So below 3, my answer is 0. Once I am becoming 3, my answer is 0.3. So 3, let us mark 0.3. The moment I cross 5, my answer is 0.5. So at 5, mark 0.5. The moment I cross 8, my answer is 0.8. So at 8, mark 0.8. And the moment I cross 10, my answer is 1. So at 10, we mark 1. Now, when I say cumulative distribution function, if I am in 4 or 4.5, my answer is that same 3 only. So extend it as a step. 3 up to 5, it is the same. Similarly, from 5 to 8, it is the same, equal to 0.5 only. And from 8 to 10, it is 0.8 only. The moment we cross 10, my answer is 1. So at 10 and above that, my answer is 1. So it goes on and on. So once I cross the highest value, my answer is 10. Now this looks like a step. So we call CDF as step function. So at 3, it is equal to 0.3. At 5 onwards, 0.5. At 8 onwards, 0.8. And at 10 onwards, 1. This is our understanding. 3 to 5, it is 3 only, 0.3. 5 to 8, it is 0.5 only. 8 to 10, it is 0.8 only. And 10 onwards, the answer becomes 1. This looks like a step. So CDF is also called a step function. We denote as capital F of x. We keep on adding. First number we take 0. 3 when I put below, it is 0. 3 onwards, that is less than or equal to 3, my answer 0.3. Less than or equal to 5, add the 2. And less than or equal to 8, add all the 3. Less than or equal to 10, add all the 4. This is our easy understanding for f of x. Keep on adding. The keep on adding only we call cumulative. And when I want to plot the graph, let us rewrite it like this way. Below 3 it is 0. So below 3 I should not mark. 3 onwards. Below 5 it is 0.3. So up to this. Once I come up to 5, my answer is 0.5. So 5 to 8, 0.5. 8 to 10, 0.8. And 10 onwards, my answer is 1. And this we call as a step function for CDF. Exercise 6.1, question number 3. Given P of x is equal to x as kx, k into x minus 2 and 0. At these values, find k. This is the question. Let us reframe the problem. X value and probability of x value. First I put 2, 4, 6 and 8. So these are the values given in the question. 2, 4, 6, 8. We have listed. Put x is equal to 2 here. So it becomes k into 2, or I will write 2k. Put x is 4, 4 into k. Put x is 6, 6 into k. And put x is 8 here. So it becomes 8 minus 2. 8 minus 2 is 6. 6 into k, 6k. Now, we have framed the table. We know sigma p of xi is equal to 1. That is total probability. The letter sigma stands for total. Total probability is 1. What do you mean by the word total probability? Add all the probability. My answer is 1. Adding all this, we get 18k. 18k is 1, implies k equals 1 by 18. So these are 2 mark problems, or sometimes they come under even 1 mark. So we must know total probability is 1. Add all this, put it equal to 1, and from which we can derive the value of k. Exercise 6.1, question number 4. Same as third problem, the table is given. We need to show that k is 0.1. Let us remember, total probability equals to 1. Adding all, k plus 2k plus 3k plus 4k equals to 1. 10k equals to 1, or k is 1 by 10, which can also be written as 0.1, and that is the problem. Exercise 6.1, question number 5. 2 coins are tossed. As soon as I read 2 coins are tossed, immediately I will write the sample space. What are the events in the sample space? I can write S is equal to, both may be heads, head and tail and head, or tail and tail. So this is the sample space for 2 coins being tossed. Getting a head is termed as success. So getting a head, here no heads, here 1 head, here 2 heads. So what would be my x value? Number of heads. And I can see there are no heads, there is 1 head, and there are 2 heads. Find the probability distribution of the number of successes. What is n of s? There are totally 4 outcomes. So we write the probability distribution. This being a simple problem, I can directly write the table. X values 0, 1, 2, and probability of x is equal to x. When x is 0, I get only TT. When x is 1, it is HT and TH. When x is 2, it is HH. So this tells me 1 out of 4. This tells me 2 out of 4. And this tells me 1 out of 4. So we can say probability of. So let us tabulate here. When it is 0 heads, 1 by 4. When it is one head, 2 by 4, and when there are two heads, it is 1 by 4. And this is the probability distribution when two coins are tossed. Question number 6. The table is given as before. We need to find certain probabilities. The very first idea, sigma pxi equals to 1. Adding all the probabilities, 0, k, 2k, 2k, 3k plus k square plus 2k square plus 7k square plus k. Together the total answer is 1. Adding all the k square, it is 7k square, 2k square, k square, 10k square. Adding all the k's, 3k, 5k, 8k, 9k, and nothing more. Bring 1 to the left side, minus 1 equal to 0. We need to solve for k. 10 into minus 1, minus 10, and I need 5, it is 10 ones are. So 10 ones are, but answer is plus 9. So plus 10 minus 1. Check it. Plus into minus minus. 10 ones are 10. 10 minus 1 is 9. So factorization correct. Let me go up to this term. 10k square tells me divide by 10k. And I can cancel this. I will rewrite as k plus 1 into 10k minus 1. Here I have k plus nothing implies 1. K plus 1 into 10k minus 1 equals to 0. K equals minus 1 or 10k equals to 1. K equal to 1 by 10. Only this is valid because probability cannot be negative. Remember, probability is always positive. If I put k minus 1, these answers would become negative, which is not allowed. So, k represents probability. It cannot be negative. So, k equal to 1 by 10 is valid. First part of the question is over. I proceed on to the second one. P of x less than 6. Now, which are the numbers below 6 in this table? X value 0 to 5 I can write. So, x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4 and x is equal to 5. These are the values which are below 6. Add all these probabilities from the table. 0, k, 2k, 2k, 3k plus k square, which is nothing but k square plus 8k. K square plus 8k. K value we already know 1 by 10. So let us substitute. 1 by 10 the whole square plus 8 into 1 by 10, which is 1 by 100 plus 8 by 10. You can use calculator, simplify and write the answer. Or else take LCM and simplify. 1 plus 18. So I can write the answer 81 by 10 or it is 0.81. The next part is P of x greater than or equal to 6. Look at the table. Equal to 6 means I must start from 6. And greater than 6, it includes the next numbers also. So 6 and 7. Greater than or equal to 6 tells me 6 and 7. So add 6 probability and 7 probability. For 6, it is 2k square. For 7, it is 7k square plus k. Total 9k square plus k. And 9, k value is 1 by 10. As I substitute, my answer is 9 by 100 plus 1 by 10. Taking the LCM 100, it is 9 plus 10. which is 19 by 100. The next question, P of 0 less than x less than 5 less than tells me 0 and 5 are not included, but the values in between 0 and 5. So this is 0 and this is 5. Which are the values in between? 1, 2, 3, 4. So we will write 1, 2, 3, 4 probabilities to be added. My answer is K, 2K, 2K plus 3K, adding which we get 8K, and it is 8 by 10. K value is 1 by 10. 8 into 1 by 10 is 8 by 10. Let us see, when they give you 0 to 5, avoid 0 and 5. Which are the values in between? 1, 2, 3, 4. Add them, write the answer. Third part of the question, P of x less than or equal to x is greater than half. X less than or equal to x. The x values are given here. Let us start from 0. Less than or equal to 0, my answer is 0. Less than or equal to 1, add these two. Less than or equal to 2, add first three probabilities, 0, k, 2k. As I add, it is 3 by 10. I am not crossing 1 by 2. My question is, when do you cross 1 by 2? So keep on adding. Less than or equal to 3. Up to 3 I have to add. 0, k, 2k, 2k. This tells me 5k, which is 5 by 10. 5 by 10 is 1 by 2. My question is not equal to 1 by 2. It tells me above 1 by 2. So proceed one more step. X less than or equal to 4 tells me 0, k, 2k, 2k and 3k. Together it is 8k, that is 8 by 10. Now 8 by 10 is nothing but 4 by 5, which is crossing 1 by 2. So when I cross, see, 1 by 2 is 0.5 value. 4 by 5 is 0.8 value. So when I cross, half is this value. And what is the corresponding x? 4. So we will write this is greater than 1 by 2 implies x is equal to 4. So when we get 4 or above, my probability is becoming half, that is more than half. So x less than or equal to 4 gives me 4 by 5, which is greater than 1 by 2. The corresponding x value they want, minimum x value. So the corresponding x value is 4 and 4 is my answer.